This is Expert Fonda and you're watching on YouTube. So in today's videos, we are solving this today contest question in the daily series. So this is a Leetcode 3335 question number of the Leetcode, and the question is saying that there is a total characters in the string we have to find after the transformation first. Okay, this is the problem title and what we have given in the statement. So let me zoom little bit. Yeah, so now read this. Okay, so the question is saying that you are given a string s and an integer t representing the number of transformations to perform. So in one transformation, every character in s is replaced according to the following rules. If the character is z, replaced it with the string ab. So if there is any character is coming in the given string, let's suppose g, then we will replace it by ab. Okay, another rules is saying in otherwise condition, if g is not coming, so other characters will come from a to y, not a to g, because g is getting replaced by ab. So a to y means other character is a to y. So replace it with the next character in the alphabet. Means it's, let's suppose a is coming, so we will replace with b. If b is coming, replace it with c, and so on. Gotcha? So it's simple. The rules is just if g is coming, replace it with the ab. Otherwise, from a to y, replace to the next character. Right? Return the length of the resulting string after exactly t transformation. Right? After the given transformation, let's suppose t will be given. How many transformations are required, right? So let's suppose for this example that this is a given string and this is the number of transformation you have to make it, right? So the after that you have to return the length of the resulting string, okay, after making the t transactions. So since the answer may vary, you have to take the modulus of 10 to the power 9 plus 7 and you have to return the answer, right? So we'll break down this problem into intuitions and we'll go through the step by logic, so you can finally understand the code and you can write by your own. So the time complexity and the space complexity will also discuss in the details. So I'll suggest please watch the full video and let's dive in. So let's understand this Leetcode question of the today contest in detail by Expert Fonda. So you are given given a string s, you can say, right, as you can see here, and integer t that represents the number of transformation, right? So t is representing the number of transformations and s is the given string. So over the given string you have to make t transformations, that you know. And better we'll go through the example that we have given in the Leetcode, right? So if you'll go through the descriptions, you will understand clearly. Okay, now it is saying for each transformation, how does this work, right? So if we talk about for the each transaction work like this, let's suppose if the character is z, right? The first rule is saying if character is z, replace it with the av, right? Otherwise replace it by the next character, right? Otherwise replace with the next character. For a it will come b, for b it will come c, and so on. That we understand. So after t transaction we have to take a modulo of 10 to the power 9 plus 7, so that you will return the correct length of the resulting string, right, once the t transformation is completed. So let's break down this example one that we have given. Okay, so example s is saying we have given a, b, c, y, y, and t is equal to 2, and so the output is coming 7. Why? So the first transaction, let's suppose we have given what, a, the first element, right? So what we will do, we'll convert a into b, right, and then we have b, that will come what, c, and d will become what t, right, and the y, right? So y will become gg, right? Means 3 character will become BCD and GG for this one, right? Means G is coming 2 times. How many times? 2 times. Means it will become 4. So next, for the next transformation if we'll do, so this was B, so it will become C. This was C, it will become D. This was D, so it will become what? E, right? Means it will come C, D, E, and this Y was G, so it will become AB, and this will become AB, right? Because this was GG, right? Means the whole resulting string after T transformation, it will become what? CDE AB AB, right? It's clear, right? So how many character will be there? So CDE is 3 character and there is 2 GG, right? It AB AB means 4, means total becomes 7. So the final string is 7. You understand, right? It's very easy, right? So what is our job for this problem statement, right? So we have to efficiently calculate the length after T transaction, that is this. If it is coming very large, take the modulo and you will return the length, right? Right? So let's take the key insights that we have given, right? So for the core intuition, if you will talk about, we have to track the actual string that would having the timeout for a big input, let's suppose more than 10,000 or lakhs, right? So we need to what we need to do. So instead of tracking characters, we should track how many each letter exists, right? So we can say, we can take the frequencies, just take like frequency, right? So for the most important, like G, right? G we are converting into AB, right? Means we are adding one more character to the length, right? Otherwise the length will be same from A to Y, right? From A to Y we are not doing any changes, so the length remains same. But when G is coming, we are updating one more to the length due to the transformation. So after each transformation, if G is there in the given string after the transaction or before, right, we are adding one more character and we are increasing the length because G is becoming AB, that you know, right? And so we can say transformation for each character, we have to track the length only, not the actual string. Means any character from A to G will be just one character only, but for G it will become 2 character. So the length increase by 1 transformation, right? So we can say for each G causes an increase in the length. For G tends to A and A becomes B, and so B becomes C and so on. So how many Z appears at the transformation to compute the final length? That we have to check, right? So the most important character is Z, right? And G becomes AB, so it adds 1 character to the length. Others like A to Y don't grow, right? They just shift forward. So what we need to do? We have to track character count in the array of size 26, right? How many characters in the alphabet? 26, right? So we have to track the character counts. So for each character, for each transaction, right, transformation, right, what we need to do? We have to add the length for every G and we have to shift all the count accordingly, right? So let's break down the problem, what needs to do. So first of all, we'll take a length and we'll track the total length. So to track the length, what we need to do? We have to track the number of G character in the current string, let's suppose G count, and for each transaction we'll increase the length plus equal to the G count. So for G it adds one more character, right? And then we'll update the G count for the next round, and for each G it becomes AB, right? And for B and for A and B, which won't be G but other characters including Y, you can turn into G. So we can also track how many characters, as we have seen there, right? Y become G and then it will come next transformation equal AB. So we are saying, so we also track how many characters exist in the 26 character, that we will see. Okay, so let's understand the to-dos to do. First, let's suppose you pause this video and try to implement by yourself. So what we will do, we will initialize the length, we'll create a array count 26 array. Why? Because to track the character frequencies, and we'll count initial frequencies from the s, and for t times means how many t given, count how many g exist, they contribute to the length increase, prepare the next count array, and for g add a and b, and for y to a to y shift to the next character. After that replace the count for the next count, and after all for the t steps return the final length while taking the modulo, right? And you can take modulo like it is saying 10 to the power 7 plus 9, right? Like that. So you take like that. Okay, so let's do implementation. Okay, better I'll suggest pause this video here and go through this step to implement. Okay, let's understand the implementation. So implementation, this is the given function we have given, length after transformations, where you have two arguments given, string and t. A string is a given string and t is the number of transformations. So first we will define mod. We'll take what, how many zeros, 7 0 and then 7, right? Means 10 to the power 9 plus 7, right? And so that this will be the mod. Take the length and create a count array of size 26 alphabet, right? Then initialize the frequency count. How will you do initial? So initial frequency for each character, you will check the counts, and you will update the its frequency in the count. Okay, now what we need to do, we'll go through the applying the transformation, right? So how we are going to apply the transformation, right? So for number of transformation, we have to take the for loop, right? Because how many transformation there? Let's suppose 2 is there, then this loop will go for 2 times. Then we will go for the next count. Let's suppose is next count is to track the number for each transaction, right? The count should be there, means the given character, like how many characters are in the alphabet, 26. So for each character we should have the frequencies, right? And for that we will create the nested next count, so that we will track the length. And for that, we'll go for all the character on this next count. So let's suppose we have all the characters, we'll check g is equal to 25, right? If g is equal to 25, we'll increase the length by 1, right? So if g is this, g becomes ab, we are adding one more length, right? How? Length plus count 25, and we'll take the mod. You will have the count 0 and count 1, and you will take for a and b, right? Because we are increasing its count, the frequency we are increasing. Okay, so we will have the next count. In the else condition, we are just moving to the next one. So we'll have the count j plus 1 is what? We will take the count of given and the given count. If the parent has already the count, that count and this count, and we'll take the mod. Okay, so in the if and else condition, we are taking the count from the count and the current count in the next count. Okay, so the next count and the previous count, right? Like let's say the original one, this is the original count, right? Original frequency, you can say original frequency and the current frequency. Original frequency means original frequency is a before the transformations, right? And for the each transformation, so we'll keep updating in the transformation count, right? So this is the transformation count of the string or characters, so we'll keep here, and this is the original one. So like that like that you have to do like that you have to do in the both side, right? From the current and the previous one. Okay, so this is for the previous one, this is the original count. As you know, we are updating original count, and for each transactions we are going for the each transaction, and for each transaction we will maintain as the count, right? You understand, right? For each transaction, this is the outer loop, and we are taking the next count for the current frequency count. Okay, and for that, how will you do? If g is coming, means g is the character, we have to add one more length. So at the next count at 0, 0 is what? A, right? And next count at 1 is what? B. So we'll take next count at 0. What is the frequency at 0? So if any times the G is coming, we will first check the current transformation frequency plus the original frequency, and we will add it, and then we'll take the mod, and then we'll update the current transformation frequency count. Okay, we'll do for the same for the B. If G is not coming, we'll maintain J plus 1 is equal to next count at J plus 1 or count at J. Similarly, we're doing for the other characters, right? We are just moving to the next character. We're taking the mode. And then we'll update the count, right? Because from the next count, we'll update the count. Because the next time will the loop for the next transformation will happen, we will reinitialize this variable, and all the maintained value in this 26 letters, right? It will be wasted. So we'll update our original transformation frequency count. Okay. And finally, we'll take the length, right? We will check the length, and we'll, you know the length, right? Length is s dot length. Okay. So we'll take the length and we'll return, because we are each time we are updating the length here. Length plus count 25. Okay. You understand, right? So please ping me in the comment box if you have any doubt in this code. Okay. Let's understand the time complexity. As you know, right, for the T transformations, and in each transformation we iterate over a fixed 26 size of the character A to G, and we are counting initial frequency of S of n, where n is equal to the length. And so we are looping over T transactions. So we'll take O of T times, because 26 is constant, and inside each transaction we are taking each operations for O of 1 time, right? So if you compute it, it will become O of n plus T, the given number of you can say the length of the given, and the T number of transactions, right? If we'll talk about the space complexity, it is coming what? Count of 26, and the next count is 26 arrays. So it will take O of 1 time, and we are not taking any extra spaces. So we will take O of 1, right? I hope you understand this video. Let's understand on the code in the Leetcode editor. And if you pause this one, right? So you will see the outer loop we have to make for this. We are transforming each one, and second loop will go for the outer one for T, right? That is why we have taken T1 and T2 outer loop for loop, and inside that we are maintaining from here. Okay, so let's understand the code. Let me increase this. Okay, so as you can see, right, first of all we have defined the initials variable, like the count, to maintain the original string frequencies. So we'll count all the initial characters. We'll do what? C minus A plus plus. Okay, then we will apply the transformation. To apply the transformation, this is the outer loop, right? This loop is nothing but the first transaction. Let's suppose this one. So 2 transaction was there in this example, T2, right? T equal to 2. So this loop will go for 2 times. First it will go for this. Once this is done, it will go for this. So this loop will go for 2 times. Okay, so the first time we have, let's suppose for these strings, right, we have maintained the count. How? We are maintaining the initial character frequencies here. We are counting the initial characters. How many characters are there? Let's suppose Y is coming 2 times, right? So if you go in the count, and if you check currently here at this position, once this is finished, right? So line number 11 will say count at Y, let's suppose at this position is 2 times, right? Frequency is coming 2 times. And for number of transformation, we have created this loop, right? And then after transaction, let's suppose for the first transaction, right, we should have this character will get transformed. How? It will become like this one. So ABC will become what? BCD, and YY will become GG. So G is coming 2 times. So who will maintain that? Not the original count, right? It will maintain the next count, right? How we will maintain this? G is coming 2 times. So we'll check in this for loop. Okay, how we'll check this for loop? So let's suppose when G is coming, let's suppose Y become what? G, right? So y, when y is 25, let's suppose y is 25, means now g becomes, right, means it becomes g. So if j is at equal to at 25, means y is coming in, like for like these two conditions, right? In that case, first we will update our length, right? Length plus count 25. So in the count 25, when y is there, the count having what? Number of frequencies 2. So the current length, let's suppose, is 25, or not the current 25. Current length is what? If you count this is 5. Now count having what? How many? 2. Count at y is 2. So the current is 5. Now we have updated count at this location is 2. So we will have the length 7. And that is why we have seen the length was coming 7, right? So for the next transformation, so this will happen, right? So after this, all the characters get updated, and the transform character will become what? B, C, D, G, Z, and you will maintain the next count, right? Like this. So from the next count, you will see that all the characters and its frequency has been changed. Okay. So we will go for the second transformations. When the second transformation comes, now the string is not what is a string? So we will get all the string at these locations, right? But we are updating the count. How? Once the first transformation got completed, right? We have updated count, next count to the count. Means the original value, this value has been replaced in the array. We are not updating in the string, but we are updating in the count array, right? That we can do, right? So these characters at the original count we will replacing here, because string is not good place to replace, right? Because due to the string constant pool, it will be costly for our application. So what we will do, we'll update our count here. Okay. Now if you'll go through updating this count, right, you will observe that this value has been updated now, right? Now we'll go for the next transformation. So in the next transformation, now what we have in the count, we have ABC, no, BCD and ZZ. Similarly, we will not see this time G equal to 25, right? We will come, all the value will come here, right? Now we will update the character like this. Okay. So this value will update it. So this is get updated. So you are just updating count j plus 1 and you are doing that. So you will update the count, right? But the length will remain 25 only. Okay. And so if you see that 25 length, it will become length 25. So when G is coming, our focus is to update the length, right? So you are updating the length. When G is coming 25, right, we are transforming to the next character G, means we have to take the count from the original one, we will update it, right? Or you can update the logic also if you want, right? But it's best to update the length only and will return. But you can do updating this value, because let's suppose it is coming, G again is coming, right? Y is again is coming, so we have to update again the length. Okay. So this is the best way to update the length, and you have the length, you are taking the mode, and finally you are returning the length. Okay. I hope you understand, guys. Let me know in the comment box that you understand, and please comment, and if you have any doubt, if you want the next topic to be discussed in this video, so I will be happy if you will give some inputs, right? And I'll create more videos for you and better videos for you in your journey. And Expert Funda wants to support your journey, and please keep supporting Expert Funda. Thank you for watching this video.